Hello, I'm Guy, and this is Guy Robot. Hello, and welcome to another episode of my blockchain Bonanza, where I'm doing a video a day on cryptocurrency and blockchain technologies. Last month I didn't do a single video because I was crazy busy working on a new startup in the cryptocurrency sector. It's a cryptocurrency trading investment fund with some proprietary AI algorithms. If you're interested in investing, it's open now at smartift.com. But my time spending that made me think that I might do a few videos covering all of the bits of crypto. Today I'm looking at smart contracts. We talked last time about what they are, and today it's, well, what are the issues with them? I finished last time on one of the benefits of smart contracts. They're immutable. That means that what you've published is what you say you've published. Everyone can verify it. The biggest problem, though, I think, of smart contracts is that they're immutable. I know it's stating the obvious, but people seeing your code might be a problem, or people at least being able to reverse engineer it if you don't publish it. But the bigger problems are you make mistakes. Like, nobody publishes code without making mistakes. And if you were to start to audit all the different smart contracts that are out there, there's potentially some costly mistakes. One of the biggest of these was an organization called DAO. The consequence of a bug in their code resulted to Ethereum actually splitting into two, which is how Ethereum and Ethereum Classic came into being. Because it was such a bad bug and affected so many people, there was a general consensus that it was worth altering the blockchain for, which is unspoken of for such a big cryptocurrency. It kind of throws it in the face of decentralization, because you've then got people that actually decide, yeah, we are rewriting this blockchain. So the immutability can be gone, but it was a lot of fallout from doing that. So you need to think really carefully when you do deployments. If it's an internal private use thing and you don't care about the fact that it'll be people want the consistency and the transparency, you can do things like have a pattern where your contract says, am I still the latest one, yes or no, and if not, it gives a redirect of where to send your messages to, or it could do a pass-through. That way, at least you know that you can upgrade it by deploying new code, which does a redirect, kind of like you would with a website. So there are options for it, but not ideal ones. Another issue with it, poor productivity. The tools are rubbish. I mean, there's a couple of different languages on top of Ethereum's virtual machine. Burstcoin had smart contracts first, but like no technology to do anything with it, so no one ever developed anything with it. We've got Solidity, which I'll cover in a future video, which is the most commonly used language on top of the Ethereum virtual machine, but it is rubbish. Don't plan on doing string manipulation, don't plan on doing too much of anything other than basic stuff. It works, but it's more like you're limited to the standard C libraries with no additional imports or functionality and no real string functionality. It's being built out though. That will be there, and there are ways you can do it at the moment, but out the box you are really limited in it. One of the other things is the cost of doing deployments, or cost of doing anything with it. You pay per, in effect, resource use, be that CPU cycle, be that memory usage, be that disk space. So if you want to store a lot of data, I mean, you're only going to store generally bytes or kilobytes, maybe megabytes in the blockchain, but the cost is about 1,000-fold compared to, say, storing that in a redundant cloud-based system with Amazon. The cost is crazy, as is the compute cost. So to give you an example, the deployment cost of all of the different smart contracts we had for SIFT came in at about $30 for 5 not that massive contracts. And when we had an original combination of them all together, it was too big to even deploy. So there are definite limits to the technology at the moment. There are ways around that. We've gone with multiple contracts that interact and call each other. It had smaller deployment cost, and it means that the attack area of each one is lesser, and it can make it easier to upgrade or move. But these are things that you need to consider when you're designing a smart contract. And part of this is also that you don't control the network or the blockchain. So if you're investing in, I don't know, a C# application that you're writing now, and you're planning to host it on Amazon Web Services or Azure, and one of those two providers goes bust, you've got other options. And if all of the providers go bust, then you can still, in 20 years' time, run a Windows Server 2012 install or 2016 install with your own C# stuff on there, and you can guarantee the maintainability of it. It's more difficult with crypto. Theoretically, you could get forks in the blockchain. Other people can make decisions that impact you. For example, the issue with the DAO split and forking Ethereum into two completely separate contracts. And because you're not fundamentally in control of all the architecture or have full access to it, it means that that immutable ledger can go against you. It also means that you're backing on a technology that might not be there. If you are really interested in Ethereum, are you committed to running enough nodes to keep the network going in 15 years' time if you're building your business technology on it? Probably doesn't matter for your small casino website, but if you're planning on really doing a business investment in it, this is where you get into running your own Ethereum blockchains, which is absolutely doable, but if you want it to be public, there's a lot more consideration here. Private, not an issue. You want something to be public, you really need to consider how you're going about doing it. There's also security concerns. Because people can fork and can theoretically create a new coin and change the data on it, well, how does that affect you if there's another currency in the future where somebody has modified what it says about the data that you've stored in there and use it in some way? Could that impact your business in any way, or the application that you're writing? So you need to consider what impact not having control of the blocks and the immutability from it comes from. And actually, I don't think it's an issue for most people, but you might want to consider it in your application development. Lastly, but kind of related, is the security considerations. That's kind of security related to your business, but more importantly, financial security. It's really easy to make a bug in code. It's really easy to make a bug in financial code. It's really difficult to deal with that when your code's mutable and can't be fixed. And this is where we've had big issues at the moment. So if you are dealing with a smart contract that issues anything of value, whether or not that's Ethereum, or it accepts or deals with Ethereum itself, if there's any value in that contract, even if it's just theoretical value expressing something that's worth a real world value or digital value, then you need to be exceedingly careful about everything. There are all kinds of things you need to deal with when you're working at relatively low level of programming. For example, somebody sends a really large payment and it overflows and sets a counter back to 0 again. Have you just wiped out all of one of your client's pieces of all your client's value in a contract? So you need to have all the checks and balances there, and most contracts don't have those checks and balances. We do in the CIF stuff, but not everyone does, and so it's important to get external audit to go through things and to see what people actually can see the issues with it. Being open source, the great things are people can find the bugs and tell you, but the other thing is they can find them and not tell you and then use them to exploit your system. So you have to be super safe before you deploy something that's immutable. Overall though, I think that the issues that come with it are minor and can be worked around. The cost performance issues are probably the worst ones at the moment. The immutability you can work around. The future of the network and the block content itself I don't really think is a big issue. The languages and frameworks are maturing. And security, if you do it right, you can deal with it. You can have security issues in online banking if you don't set it up and code it right, or any financial system. But when it comes to cost and performance, it feels at the moment it's very expensive to interact with and deploy smart contracts compared to, say, a month of hosting your own server on a cloud-based service. And the performance for the length of time it takes to do things again isn't amazing. But this is in its infancy, and I think as far as those maybe are some of the specifics with Ethereum at the moment for those latter ones, and as it moves forward into the future, I think this definitely has amazing benefits and potential. And so that's it for today, but the next video I'm going to look at what that potential in the future for smart contracts is and how we might use them. Hopefully you found today useful. If you have, please thumbs up, like it, and leave a comment below. And also please go over and take a look at Sift. All of the source code for our smart contracts are over there, and you can also look at maybe you're interested in investing with some 40% returns for our cryptocurrency investment fund. That's at smartift.com. Link also in the description below. And I'll see you tomorrow. Thanks.